Hello, awesome scholars. Today's lesson is going to focus on balanced and unbalanced forces. Now, as you can recall, balanced forces are those forces that do not have any movement. Unbalanced forces are those that cause movement. If you can remember the demonstration we did with the guys pulling their hands, and then with the skateboard, remember, as long as each person was pulling with an equal and opposite force, then there was no movement. But of course, once the forces were unbalanced, then there was actually some movement there. So we've already talked about acceleration and force, and most of the times, well, actually for every problem we've done, there's always been an acceleration that was applied to the force. Well, in some problems, you will see something that says constant velocity. And let's see, what does this really mean? Constant velocity means that there is no acceleration. Now, if there's no acceleration, that means that the acceleration is equal to 0. But when you think about it, if you put in a 0 into the F equals ma equation, what's going to happen is that means your overall force will be 0. And that can't be the case because we actually want to have an answer to solve for, so we don't want our force to be 0. So when you think about constant velocity and there being no acceleration, don't think about acceleration being equal to 0. Instead, I want you to focus on this right here. That if there is no acceleration, there's constant velocity. The force in the up direction equals the force in the down direction. At the same time, the force in the right direction equals the force in the left direction. So again, if there's no acceleration and you see we have constant velocity, I want you to focus on the fact that that means that the force in the up direction is equal to the force in the down direction, and the force in the right direction equals the force in the left direction. And so what that means is that F net will be equal to 0. So that should be pretty simple for you to understand. However, if you still have trouble understanding that concept, you can always email me, or you can see me sometime at school. Now, this is just kind of rehashing what we talked about a minute ago, that when the velocity and direction stay the same, there's no acceleration. So if there's no acceleration, or if equal to 0, then the net force equals 0. Now, if the net force is equal to the force in the moving direction minus the frictional force. Well, if there is no net force, that means that the force in the moving direction is equal to the frictional force when there is a constant velocity. Now, let's look at the homework problems that are on the back of the little packet we have here. I want to go through each of them with you so that I can make sure that you understand the concept and actually how to solve them. Alrighty. So it says we have a 12-kilogram crate that is traveling upwards at a constant velocity by way of a crane. So we want to determine the force that the crane is applying to move this crate upward. Now we see these words here, constant velocity. So that means that we have no acceleration. But what this means is that force up equals force down. Right? So let's do our little diagram here. So here we would have 12 kilograms. That should be a 12. And here, of course, the force of gravity. And this right here, there we go, would be, let's just call this F1. Right? Now, because we said it's a constant velocity, and the force up is equal to the force down, that means that whatever the force due to gravity is should be the same as the force that's been applied in the upward direction. So let's calculate it. We know F of G equals M times A of G, which should give me 12 times 9.8, which should be 117.6 newtons. That means that this is also that value. So F1 equals 117.6 newtons, because constant velocity and no acceleration. So make sure you understand those. Okay? So that was fairly simple, or at least I think so. Now we're going to skip the second problem, so don't worry about having to do that, because the problem 2 involves a normal force that we did not talk about in class, so we're not going to worry about that at this point. So let's go to problem number 3. Now, problem number 3. A piano is being lifted with a force of 900 newtons. If the piano is traveling at a constant velocity, what is the mass of the piano? Well, I got my piano here. I know there's a force lifting and also obviously there's a force coming down. Now, again, we see this constant velocity. Because it's being lifted, we know F up equals F down. So we don't have to do any calculation here, because guess what? If F up is 900 and we have a constant velocity, which means that the two forces are equal, that means that this right here should also equal 900 newtons. Now, the problem did not ask for that. The problem asked for what is the mass of the piano. So in this case, we would use F of G equals M times A of G, because it is being lifted. So we substitute 900 equals M times 9.8. I'm going to divide both sides by 9.8. Cross that out. And if I did my math correctly, I should get 91.8 kg for my mass. So again, don't forget, constant velocity implies no acceleration, which means that every force up equals every force down, and then of course the forward and backwards or left and right directions are equal as well. All right, problem number 4. 12 kilogram suitcase is pulled to the right with a force of 150 newtons applied at a 32-degree angle. A frictional force of 15 newtons is also present. What is the acceleration of the suitcase? Well, here we see we have an angle, so that should signify that we will have a triangle. Okay? Now they told us the angle was 32 degrees. The force is 150 that is being pulled. Righty? And basically we want to know what the acceleration of the suitcase is. Now, since the suitcase is being pulled to the right, we're worried here about horizontal motion, not necessarily vertical motion. So that's what we need to find what x is. Righty? Now remember, x equals, sorry about that. Alrighty. So x is, well, to solve for x, we would do the cosine of 32. Let's make these actual dots so you don't think they're. So cosine of 32 equals x over 150. That's a 0, by the way. Right? So to solve, 150 cosine 32 equals x. So 127 newtons is equal to X, which is the force in the X direction. Now, we don't want that. We want the acceleration of the suitcase. But what we need to do now is to find out what the net force is. All right. So to get the net force, I'm going to do F net equals force in the moving direction minus the frictional force. That should be an F, not a G, which equals 127 minus 15. So the net force is 112 newtons. Now I just want to solve for the mass. Notice I'm sorry, acceleration. So F net equals MA. So 112 equals 12A. And when I divide both sides, so 112 over 12 equals 12A over 12. So my final answer will be 9.3 meters per second squared is my acceleration. Right? So again, if you see an angle included in the problem, make sure that you do your triangle and resolve whichever component you're looking for. Now, like I said, it was not necessary for me to determine what the vertical portion was because the box is being pulled in a horizontal direction, so all we needed was the X force. Right? Now I have 6 practice problems here for you to work on, so I want you to solve these and make sure that you are comfortable with doing these problems. And of course, you can follow the examples that I just completed with the 3 homework problems. As always, if you need an assistance or any help, please feel free to email me or just see me doing Flex tutorial before or after school, and we can make it happen. Hope you all have a great weekend.